Looks like everybody's like late to the party today. If you are in here, let me know if you're having trouble listening or hearing. I have the mic now above me rather than to my side because it was getting in the way and the cord was broken. So I'm trying to fix it. What's going on, Tabitha? So yeah, just let me know if you have any trouble hearing anything that I'm saying. I can always turn up the mic if need be. I mean, it shows that my computer's picking up the mic pretty well, so I'm just going to assume that it's okay. Let's see here. Yeah, some people are starting to fill in now. But we are going to finish up this lesson 7. We did the front page. I introduced you guys to a few new words, a few old words when we started doing shifts. And then I'm going to talk about this new word a little bit more today. It was called a midline. It does sound a little weird. I can always, like I said, it could just be the microphone's just in a different place. That's all. So it is up here. So I can move it down a little bit more. Maybe that will sound a little bit better. Anyways, yeah, just let me know. If you guys need me to turn it up, I'll turn it up. But, so, big key word from yesterday was midline. So I'm going to extend on that on the next page. So I'm going to try my best today to avoid using the calculator so you guys can see how you can find all of these solutions without actually having to type in every single piece into that calculator. Sometimes you might have to, and that's okay. But my goal is to try to show you ways to avoid that. Okay? So, exercise number 3 says sketch and label the functions f of x and g of x on the grid below. So we have 2 different functions. So the first thing I'm going to do before we go into the sketches, I want to make sure that we can identify the midline of these functions and the range of these functions. And you know what I'm going to do? I'm going to do the midline first. I'm then going to graph it, and then I'm going to do the range. I think that's how I'm going to do it. Yeah, and I agree, Tabitha. That's how I'm at. I know not everybody doesn't feel as confident just counting. They feel a little bit more comfortable and more confident seeing the answer pop up in the calculator. So I'm okay if you guys still want to use it. It's just sometimes some of these problems will take you forever if you just keep typing in the calculator over and over again. So I'm going to scroll up for a second, just going up to exercise number 2 because I just wanted to do the last part that we talked about yesterday. Noticed I highlighted this +1 and I drew an arrow all the way down and I said, hey, that's the midline. So the midline is the horizontal line that is equidistant from the max and min values of your function. So we don't have to graph anything because what I want you guys to recognize is anytime we have a midline, the midline is just whatever number you are adding or subtracting on the outside of the parentheses. So if we were to do f of x, the midline would be at y equals -2. So that would be the midline for that function. And I should probably do different colors. You know what I'm going to do? I'm only going to do f of x right now. The only reason why is because I don't want to confuse anybody on the graph that we're about to do. So we'll only do f of x. So f of x, the midline is y equals -2. So what I'm going to do on the graph is I'm going to draw on the midline. But the midline isn't technically part of the graph. So what we're going to do is we're going to draw it in as a dotted line. So I'm going to come down here at y equals -2. And I'm just going to draw a dotted line all the way across. So this is just known as the midline. It's the middle line of the function. It's not actually part of the function though, and that's why it's dashed. The other thing that we've talked about is the number that comes out front. And that's this number right here. So on the front page, I could scroll back up, but I'll just reiterate it. This number is known as our amplitude. So I'm going to show you guys a shortcut for graphing these because we're going to have to do very, very little counting today. So when you go to do the amplitude is how far up and how far down you are from the start of your graph. Now, when we did the graphs the other day, we didn't have a midline, so we always did it from the middle, the x-axis. But now that we have a midline, what I want you guys to do is when you get an amplitude, I want you guys to recognize that this is how high up and how far down you go from that midline. So I'm going to count up 4. I'm just going to put a little dot. I'm going to count down 4. I'm going to put a little dot. And you know, I'll even do a dashed line through this too. And now these dashed lines are not necessary, but I'm showing it for note purposes. So the purple line is right in the middle, and we know the blue lines are going to represent the highest point and the lowest point of our graph. Even though we don't know what the graph looks like yet, we do now know the highest and lowest points. Well, we also know what that is called because the highest and lowest points are known as the range. So if I asked you guys to tell me what the highest and lowest points are, we can already figure that out based on the graph we just drew. The lowest point we just said is way down here, and that's at 1, 2, 3, 4, 5. That's at -6. So that little dot right there is at -6. And it goes all the way up. We're doing range, so they're the y values. It's going all the way up to +2. So it cannot get any bigger than 2. It cannot get any smaller than -6. So we know it's all in between there. All right, so now we got to talk about how the graph works. So the graph is always going to alternate going up and down. So this is a sine curve. Now this is going to sound a little weird. So sine, I've been telling you guys. I said this in the lesson last week. Sine always starts at 0. But we cannot start this sine curve at 0. So I'm going to draw something, but I'm going to erase it. I can't start it at 0 because if I'm starting there, it's not going to be in the middle of the graph. So what I should be saying is sine starts on the midline. So I don't want to start it right at the center. I don't want to start at 0, 0. I want to start it at 0, whatever the midline is. And I will show you guys on the calculator as well after I'm done with this, so everything we're doing is going to match up. So I'm going to start at 0. Now, the original function said that I had an amplitude of 4. Since this is a +4, this is going to tell us that the graph is going to go up 4. So I'm just going to go over to the next number, which in this case is pi/2. And I have to go up to the 4th spot. I can't go any higher than that, because if I go any higher than that, then it's not part of the function, because we said that the function has to be between -6 and 2. Now remember what we did on the previous page and previous lessons. When you guys are doing those sine and cosine curves, once it goes up, it needs to come back down. So I went all the way up to +2, and now the curve is going to start coming back down. And when it starts coming back down, so now we're going to go over to pi, it always goes back to where we began. So now I'm going to come all the way back down to where that midline is. But when we do our graphs, we said that we have to reach the maximum point, and we also have to reach the minimum point. So I went all the way up to the max, and now I'm going to come all the way down to the min. And we said the min was going to be at -6. Now when I get to 3 pi over 2, I'm going to be down here at -6. And then again, these graphs go up and down, up and down. So we have to go all the way back to where we begin. I know that what I just drew is a sine curve. And the reason why I know it's a sine curve is it kind of, sort of, looks like the letter S. I know it doesn't look like a perfect S because it's kind of like flipped upside down and everything, but it kind of looks like an S. So now I know that I drew the correct sine curve. I just have to make sure that I do it for the negative side as well. So because we started here in the middle and we went up, when you go to do the negative side, you're going to go in the opposite direction. So we can't go up because then it's going to be a reflection, and we don't want it to be a perfect reflection. What this is actually doing is coming down here first, and then it's working its way back up just like it did before. So it repeats itself. It has to look exactly the same on both sides. It's not going to be a perfect reflection. And as you guys can see, that curve does look pretty similar on both sides of this graph now. What we just did is we drew the sine function without the use of a calculator. Now I know what I just did was the first time. So a lot of you guys are going to kind of be like, I don't quite have this. Okay? Yes, that's all you have to do, Tabitha. Okay? So I'm going to do all of this again, but I'm going to do it with g of x. Okay? So this is what I'm going to recommend. This is what I'm going to recommend to try and make life a little bit easier. I think this is going to... Oh, I just froze. So hold on one second. What I'm going to do is I'm going to copy this entire graph. So I'm going to copy this entire graph. Now, I don't know how this is going to work, so let me see how this is going, because I want to copy everything. Will this copy the graph too, or will it only... I want the grid. Isn't there a way that I can copy the grid too? Convert to text, style, no? Undo. Can I copy the whole image? Am I not allowed to do that? Well, that stinks. Alright, well then this is what I'm going to do. Alright. But paste image... Oh, I see what you guys are saying. I see what you guys are saying. Okay. So if I do paste image, alright. But now if I paste image, can I erase the colors that are on there? No, I cannot. Okay, so this is what I want you guys to do then. Because I don't want you to erase... Oops. I don't want you guys to erase all of your work. So I know what to do now. Alright, let me delete all this. I don't want this here. You go away. Delete. Alright, start from scratch. So what I'm going to do is I want to take this right here, and I'm just going to move... I'm just going to cut it for right now. No, because if I cut it, it's going to erase it. Alright, I got to move it. I'm going to move this down to this last page right here. Okay, I'm just going to put it off to the side. I know what I'm doing. I promise. We'll move it back up in a second. Alright, so this was our sine curve. I wanted to free up the space. So we can start over and do g of x now. Okay, if that makes sense. So now I want to graph the next curve. I want to graph this guy up here. So I'm going to do all the stuff very, very similar. I'm going to walk you guys through it. And then we'll see if you guys have any questions after we do that. Okay? So the first thing that you guys have to do is figure out what the midline of g of x is. Okay? should have moved this down too. I'll just move that off to the side. So we have to figure out what the midline is. So the midline is whatever the number is that you're adding or subtracting at the end of the function. So in this case, it is at positive 3. So I'm going to go up to positive 3, and I'm going to draw in a dashed line. So this is not the function. This is just going to be the middle of our graph. Okay? So g of x has a midline at y equals 3. So that's the middle. We also need to find the highest point and the lowest point. Okay? So the highest point and lowest point is determined based on the amplitude. So just like we did in the last one. So the amplitude says that it is at -2. So the thing is it doesn't matter if it's positive or negative. It just tells us which direction that we're starting at. So this one's going to say that we're starting in the negative direction, but we're still going to go up 2 and down 2, just like we did in the last one when we went up 4 and down 4. So because it's a 2, I'm going to go up 2, and I'm also going to go down 2. And again, I'm just going to draw in my dashed lines. Okay. Now cosine is a little bit different than sine. So sine starts on the midline. Cosine is just going to be slightly different. I'm going to do this one in orange. Cosine starts, I don't know why I started writing there because I'm never going to fit everything in. Cosine starts based on the leading sign. So it's going to be the leading sign. So the leading sign in this case is a negative. So what it's telling you to do is when you're looking at your range, you're going to start on the negative part of the range. And now you're going to ask yourself, there are no negative range in this because the range, if we were to look at this, is at +1 and it's also at +5. So you're like, it's not negative, they're both positive. So what that really means is you're going to start at the smaller number. So because it's at -2, or since the leading sign is negative, what we're doing is we're going to start at the bottom. So if it was a +2, we would start up top by where that 5 is. So it will always determine your starting part of your function. So sine will always start on the middle. Cosine will either start at the top or the bottom based on whatever that sign is. Okay. So now that I have that, now I have to follow through with the cosine curve. So because we started at the bottom, we can't go down anymore because then we're not going to be within inside those blue lines. The graph can only be between these blue lines. So I know I have to start going up first. Well, if I start going up, it's always going to alternate between the middle and the top. So when I come over here to pi/2, I have to go through that middle line in order to get to the top. So I know my next dot has to be on the midline. I'm then going to come over to pi. So I already crossed through the midline, so now I have to reach all the way to the top of the function. I'm going to put in that dot. Well, now I reached the top of my blue dashed line. I reached my max. So I have to start working my way back down. So if I work my way back down, I'm going to hit that 3pi/2 because I have to cross through the midline again, and I'm going to reach all the way to the bottom. So if I were to connect all of these dots, I'm going to have a curve that looks something like that. That curve is known as our cosine curve because if you look at it very carefully, it kind of looks like the letter C. Kind of, sort of. It's not perfect, just kind of, sort of. Okay? Now we also have to do it to the other side. So if we go to do it to the other side, it's going to be the same thing. It's just going in the opposite direction. So this is going up both ways. This one would be a reflection, unlike the one that we did earlier. So I'm going to go up, I'm going to go up, and then I'm going to come back down. Because the cosine and sine curves always repeat themselves. So it should look exactly the same on both sides. Okay? So again, these can be a little confusing as you guys go through them. All right? So the only thing that we really cared about in this whole thing is just the orange line. The blue dashed line and the pink dashed line is just a guide to help you guys place the dots if you're not going to be using a calculator. Now, if you guys prefer to use the calculator, I could have still went into y equals. I can still type in, if let's say we just did the cosine one, I could still type in negative 2 cosine x plus 3. And I can go into my table. Let me delete everything I have there. And let's say I start at the beginning and I want to type in negative 2 pi. If I type that in, it says my answer is 1. So now what I can do is I can just go over to negative 2 pi and check to make sure that is 1. And it is. So that checks. Now I can type in negative 3 pi over 2. And the answer should come out to be 3. So you could do that individually if you want to do it that way. There's no problem with that. I'm hoping that we can try to avoid doing that for the future because that will start to slow us down if we have to type each one in. Right now, it's still very, very new. So if you need that calculator, don't be afraid to use it, especially when it comes to the homework. Okay? Of course, I moved the calculator and then I froze. There we go. So now I'm just going to take this. So the only reason I moved that down is because I didn't want it to be confusing with what we were just doing. Now I could put it back to where it was. Now if you guys look at everything I just drew and I overlap them, that does look pretty confusing, doesn't it? So that's why I wanted to do it separately. Okay. Do I still have the image pasted on here? No, I don't. That's fine. So, that being said, I'm going to scroll down to number 5 first, because number 5 is the same type of question we just did, except it's working backwards. This time I gave you the graph, and I'm going to have you guys go backwards and tell me what the midline and the amplitude are. So it says, the graph below shows a sinusoidal curve. Sinusoidal just means it could be sine or it could be cosine. We don't really know. We can make a guess at it, but you can't assume. So sinusoidal curve just means, hey, look, we got a sine curve, we got a cosine curve. So it's in the form of a sine x plus c. So the a is at the beginning. That is always known as your amplitude. And that c is on the outside of the parentheses. And if it's ever on the outside of the parentheses, that is going to be known as your midline. So we're going to find both of these. And it's actually a very, very easy concept when you go backwards like we're about to right now. Because the midline is going to be the line that goes right through the center of the curve. So what I'm going to do is I'm just going to draw a line that goes right down the middle of the curve. That is our midline. I'm telling you, this is one of my favorite definitions in math because midline just means middle line. There's no overthinking for that. So now that I drew in my midline, the goal is to figure out what that midline can be. Well, in order to figure out that midline, what I'm going to do is I'm going to draw in my dashed line up top, just like we did before. And I'm also going to draw in a dashed line at the bottom. And the reason why I'm going to do this is because you're already given the values for those blue lines. Notice where they cross the y-axis. The top one crosses through the number 22, and the bottom one crosses through the number 6. So what I want to know is if 22 is the highest point and 6 is the lowest point, what is the middle going to be? Well, in order to figure that out, what you guys can do is just find where the middle is going to be located. So in order to do that, just subtract the two numbers. So if I subtract the two numbers and I do 22 minus 6, that's going to give me, if I do 22 minus 6, that's going to give me 16. Now that doesn't mean that's in the middle though, right? Because if I put 16 there, 16's not in the middle. So there's still one more step here. Remember what we said about amplitude. Amplitude is how high you go and how low you go. So it's going to go into two directions, but it's going to be the same distance. So I have to figure out the distance from here to here, and I have to find the distance from here to here, but they should be exactly the same. So after I subtract those two numbers, I can divide it by 2. Because it's got to be exactly the same, and if you ever divide something in 2, it's always going to be the same number. Well, that's going to give us 8. So if I say that this number right here is 8, that means this number right here has to be 8, because they're the same distance. Now I can figure out what the midline is. Well, the midline, if I were to do 6 plus 8 and I go up, is going to be at 14. So the midline is going to be at 14. My pencil, there it goes. And to check to confirm this, I can always go back down from the 22 as well. If I do 22 minus 8, that's also going to be 14. Okay, so we now know the midline. I also need to know the amplitude, but we already did the amplitude. The amplitude is how high up you went and how low you went. And it has to be the same number, which is what we did right here. We said that we had to go up and down 8 from the middle. So our amplitude would be 8. Okay? So this is working a little bit backwards, but what we're doing is we're going back and using just the average. We have to subtract the highest and the lowest, and then we just divided it by 2. Okay? I know we're going to go a little bit over today, but I just got to show you guys one more thing, and that's just going back to question number 4. It's going to be very similar. It's still talking about these two things. We have to find number 4. It says using the information, it says above, but I guess it's saying from what we did above. We can locate the range of any curve by looking at the midpoint and the amplitude. So in number 4A and B, we know what the amplitude is. We can say the amplitude is 7. We know what the midline is. We can say the midline is 4. But I want to know the range. So I'm going to do it by drawing a picture. Some of you guys can probably do this off the top of your head. But what I'm going to do is it says, hey, the midline is at 4. So what I'm going to do is I'm going to draw in my dotted line through 4. Amplitude tells us how high we go and how low we go. Well, the amplitude says that we have to go up 7. So I have to go up 7. So I have to add 7. Well, if we do 4 plus 7, that's just going to be 11. But amplitude also says we have to go down the same amount. So we're also going to go down 7, which means we have to subtract 7. So if we do 4 minus 7, that's going to give us the lowest part of the range. And 4 minus 7 would give us negative 3. So now if I ask you guys to write the range, we know the smallest number is negative 3, which is less than or equal to y, and it goes all the way up to positive 11. So those are the two important things about today. Amplitude will always represent how high and how low you are from the midline, and the midline is just the middle line. Okay? I'll run through that last one too, just so you guys have it. I'm going to move that down a little bit. I'm going to do it without a graph this time. So I know, again, I should start off with this. My amplitude is negative 5. My midline is positive 2. Based on what we did in the picture, you have to start at the midline, and you have to add on the amplitude. So I'm going to add on 5. I'm also going to start at the midline, and I'm going to subtract the amplitude. So I'm going to subtract 5. And if I find those two answers, I'm going to have 7, and I'm going to have negative 3. What we just did without graphing it is we found the range. So the smallest number would have to be negative 3. Since we're talking about range, we have our y's, and the largest number is going to be 7. If it helps draw in the picture, you may do so, but I'm never going to require you guys to draw a picture. This is more about understanding the vocabulary. All right? So I know we spent a little extra time going over this today, but I just wanted to really make sure that you guys got this vocabulary down. Tomorrow I'm going to introduce 2 new vocabulary words, and then like the lessons that pertain after that is going to be mixing all the vocab words together. So we'll put all the vocabulary words all into one lesson, and then we'll just kind of practice. It will be like a review day. So if you guys still are kind of like, with this, it's okay. We're going to come back. We'll do some more with it. Do the best you can on the homework. If you can't do it based on how I did it today without the calculator, just use the calculator. Okay? It's not frowned upon. It's all okay. As we start going through it and getting more practice, I'm sure you guys will feel a little bit more comfortable. All right? Homework is going to be, did I not download homework 7? Front page is 2 graphs, I believe, so you have to draw the graphs just like what we did. And then the back page asks a couple questions with the range. And it starts talking a little bit more about the midline and the, amplitude. Okay? So stop by Zoom if you got questions. Shoot me emails if you got questions. Hopefully I didn't confuse the heck out of all you guys. And this is probably one of the hardest lessons to teach, like, virtually. It's a lot easier to teach in person because we can bounce ideas off each other and we can understand why certain things are occurring. Okay? So I'm going to leave it there. I have to go prepare for my pre-calc lesson that I'm doing for the Math 12 class. So, again, hit me up if you got questions. Otherwise, I will see you guys tomorrow for lesson number 8. All right. See you guys.